In this video, we'll discuss about the lung capacity. Okay. So like I said in the previous video, lung capacity denotes the amount of air which your lungs can hold. Okay. So how the lung capacity can be calculated? The lung capacity can be calculated from the lung volumes itself. Okay. By taking up the summation of these volume, we can find different lung capacities. So first we'll see which are the different lung capacities. Okay, there are different lung capacity. First one is the inspiratory capacity. I'll just write IC. IC for inspiratory capacity. And second one, obviously it is expiratory capacity. Okay, EC stands for the expiratory capacity. Third one is FRC. Okay, FRC, that is functional residual capacity. Okay, FRC means functional residual capacity. Next one is VC, that is vital capacity. And the last one is TLC, that is total lung capacity. Okay, so we'll see each of this. First one is inspiratory capacity. Okay, so from the name implies itself, it deal with inspiration. Okay, so inspiratory capacity, the capacity of your lungs in inspiration, the amount of air that can be taken into the lungs during the inspiration. Okay, so it will be including normal plus forceful, right? So inspiratory capacity, how can we calculate inspiratory capacity? So let me give you the definition of inspiratory capacity. Inspiratory capacity is the amount of air that can be inspired through a forceful respiration. Okay, you know that forceful respiration obviously contains the tidal volume also, right? So if you are taking a forceful respiration, that means you are taking as much of air as you can. So that forceful respiration also includes tidal volume. Okay, so it includes the tidal volume and what else? The inspiratory reserve volume. Okay, so these together forms one forceful inspiration. So tell me, let me tell you how much air that can be inspired during one forceful respiration. It is tidal volume plus inspiratory reserve volume. Okay, so inspiratory capacity is tidal volume plus inspiratory reserve volume. Okay, this together constitutes one forceful respiration. So the amount of air that is forcefully inspired, that can be forcefully inspired by the lungs, it is what? 500 plus 3000. So it will be 3500 ml. Okay, this is in the case of a normal person. Okay, no, that is a person with no respiratory problem can have inspiratory capacity 3500 ml. Okay, I hope this is clear to you. Next one we'll see about the expiratory capacity. Next one we'll see about the expiratory capacity. Okay, just like the inspiratory capacity, expiratory capacity is the amount of air that can be forcefully expired from the lungs. Okay, so that will be including what? Tidal volume plus the expiratory reserve volume. Okay, one forceful expiration include the volume of the tidal volume. Tidal volume is during any normal respiration we are taking in and giving out a certain amount of air, right? That is what is called as tidal volume. Okay, so even if you are forcefully respiring, forcefully expiring, the tidal volume is also including in that. Okay, this is an inspiration. After when I attain the peak, I am giving out a forceful expiration. Okay, so this air contains the normal tidal volume along with the additional volume. Okay, so the total amount of air that can be given out through forceful expiration is known as the expiratory capacity. Okay, so it will be obviously involving this, including this tidal volume plus expiratory reserve volume. Okay, inspiratory reserve volume, that is inspiratory capacity, is the amount of air that can be inspired through a forceful inspiration, and expiratory capacity is the amount of air that can be expired through a forceful expiration. Okay, so third one is how can we calculate this? Tidal volume is 500. Okay, normal tidal volume is 500. Let me tell you, this value can fluctuate. Okay, the value can vary from person to person. So for convenience only, I am taking one value. Okay, this all comes in a range. Okay, so 500. What is the ERV? ERV, expiratory reserve volume. It is mostly 1200 or 1300. Okay, it all comes in same range. Okay, we'll take 1300. So 500 plus 1300 ml gives 1800 ml. So we can say that the amount of air that you can forcefully expire is 1800 ml. Okay, so inspiratory capacity and expiratory capacity is, I hope it is clear. Next one is functional residual capacity. Okay, there is one term, residual. Residual means something which resides. Okay, air can be reside. We have just seen some air can be resides within the lungs even if we are having a forceful expiration. Okay, that is what is called as the residual volume. Okay, so this capacity obviously includes residual volume. So functional residual capacity is the expiratory reserve volume plus residual volume. How comes this? That is the total amount of air that is in the lungs during expiration. Okay, let me tell you again. FRC, by definition, it is total amount of air within the lungs. Okay, it is not about air in movement, but the air within the lungs that you can expire. Okay, so we know that already a volume of air is there in the lungs. Okay, along with that you can expire some amount of air. Okay, so these together forms the functional residual capacity. Right. Okay, so functional residual capacity, that is the amount of air in lungs. Okay, this is most important. During a forceful expiration, for performing a forceful expiration, what amount of air should be there inside your lungs? Okay, so inside the lungs there is always a volume of air. Okay, we cannot compromise that. There is always a volume of air residing within the lungs, that is known as the residual volume. Along with that, it is also containing air that is going to be expired. Okay, for performing the expiration, what all amount of air is have to be contained within the lungs? The expirated air and also the air within the lungs. Okay, so during a forceful expiration, the air within the lungs are expiratory reserve volume and residual volume. Okay, so expiratory reserve volume is 1300. What is reserve volume? Residual volume, it is 1200. So it is 2500 ml. Okay, so the functional residual capacity normally it is having a normal value 2500 ml. Okay. And next, lung capacity is vital capacity. First, let me give you the definition of vital capacity. It is the total volume of air that can be bring in forcefully and expire forcefully. Okay, vital capacity is the total amount of air. It includes all the amount of air that will be involved in forceful inspiration and forceful expiration. Okay, so we know that during a forceful inspiration, which all the amounts of airs are included, the tidal volume and also inspiratory reserve volume, right? And during expiration, what is required? One tidal volume and one expiratory reserve volume. Okay, so vital capacity is the value which we'll get by summing up all these values coming between one forceful inspiration and one forceful expiration. Okay, let me give you the definition again. The vital capacity is the amount of air that can be forcefully taken in and forcefully taken out. Okay, so it includes all the amount of air that comes between this forceful respiration. Okay, so we can say that vital capacity includes tidal volume. So you can ask, we are taking one tidal volume, we are taking one inspiratory reserve volume. Again, we are having an inspiratory reserve volume of expiration, right? So let me tell you, we do not want to take two. That is tidal volume is 500. Okay, it does not change whether it is going out of the lungs or going entering into the lungs, doesn't matter. There is one value for tidal volume, it is 500. So we will take the tidal figure as 500 only. Okay, so what are volumes that is included in the vital capacity? First one is the tidal volume. Okay, just let me tell you. Here you see, this one is the tidal volume. Okay, after the tidal volume, we'll take one inspiratory reserve volume. Okay, this is inspiratory reserve volume. This is tidal volume. Okay, and we'll take one expiratory reserve volume also. So from here to here, this is expiratory reserve volume. Okay, these together forms the vital capacity, the amount of air that can be forcefully in and forcefully out. Okay, more specifically we can say that the amount of air which are in movement. Okay, all these air can be moved. Tidal capacity is the air that is taken in. Inspiratory reserve volume is also taken in. Expiratory reserve volume, it is given out. So the air which is in movement, right? So it includes all the air which is in movement. That is what is called as the vital capacity. Vital capacity, so we can say the formula, that is tidal volume plus inspiratory reserve volume plus expiratory reserve volume. What is tidal volume? It is 500. What is inspiratory reserve volume? It is 3000. So total it is 3500. And also in expiratory reserve volume, that is 1300. So we'll get a total 2800 ml, right? Sorry, it is 4800, okay? we'll get a total amount of 4,800. 500 plus 3,000 plus 1,300 gets 4,800 ml, that is vital capacity. So the total amount of air that you can forcefully take in and out, it is 4,800 ml. Okay, and next we'll discuss about another capacity, that is total lung capacity, TLC. Okay, let me give you the definition of total lung capacity. Like the name implies, the total amount of air, okay, including the air in movement and also air within the lungs. Okay, so we can say that all this air, the capacity of the lungs to hold all this air is total lung capacity. Okay, from this graph itself we can say what is the total lung capacity. It is 6,000. Okay, we'll see how it comes 6,000. Okay, total lung capacity is the total volume of air that can be occupied in the lungs. Okay, it is the capacity of lungs. It is the maximum capacity of lungs to hold the air. Okay, just the capacity of air, capacity of lungs. Okay, so we can say total lung capacity. Total lung capacity equals tidal volume plus inspiratory reserve volume plus expiratory reserve volume plus residual volume. Okay, all the volumes of air together forms the total lung capacity. That means the lung can hold this much of air. The lung is performing all these functions. That means all these movement of air, and also the lung is having a residual volume inside it, right? So the lung is the one that holds this much of air. Okay, so we can say that total lung capacity equals tidal volume plus inspiratory reserve volume plus expiratory reserve volume plus residual volume. Okay, what is tidal volume? It is 500. What is IRV, inspiratory reserve volume? It is 3,000. What is expiratory reserve volume? It is 1,300. What is a residual volume? That is 1,200. Okay, so we'll get a total amount 6,000 ml. That means the lung can hold 6,000 ml. The lung capacity is 6,000 ml. The lung is having the capacity to hold maximum 6,000 ml. Okay, so we can say that it includes all the amount of air, okay, whether it can be the amount of air which are in movements. Did you understand what is air movement, which can be expired or inspired? Okay, that is what is called as air in movement. And also it includes the residual air volume. Okay, the air volume which is seen inside the lungs is residual volume, along with all the airs, along with all the volume of airs which is involved in movement, also have to be taken into consideration. Okay, so total lung capacity is the total amount of air which the lungs can hold. Okay, so it includes all the amount, all the volumes of air inside it. Okay, so in short, let me tell you, lung capacities are of 5 types. First one is the inspiratory capacity. Inspiratory capacity, for a forceful respiration, how much air is required. Okay, for a forceful inspiration, the lung can hold maximum how much amount of air. Okay, so it includes one tidal volume along with inspiratory reserve volume. Understood? And next one is expiratory capacity. Expiratory capacity is the amount of air that can be expired out during a forceful expiration. Okay, you should not be confused. It is not normal breathing, it is forceful breathing. For a forceful breathing, you know, obviously there should be this 500. Okay, for a forceful expiration, you will take a forceful expiration after an inspiration, right? From this level, you're giving out first the tidal volume and then you are giving out additional volume. Okay, so for a forceful respiration, you will take this much of air. So 500 plus 1300, so it is 1800 ml that you are giving out during a forceful expiration. Okay, and third one is the functional residual capacity. Okay, that means during an expiration, how much amount of air is occupied within the lungs. Okay, it is not gone out yet, the air is still inside the lungs. So how much of the air is inside the lungs during an expiration? Obviously there would be some volume of air within the lungs always. Okay, that is what is called as the residual volume. Okay, so besides the residual volume, the volume of air that you are going to expire, that is also contained in your lungs. That is why you are expiring, right? So the expiratory reserve volume along with the residual volume gives you the functional residual capacity. Okay, so next one is the vital capacity. What is vital capacity? The total volume of air that can be forcefully breathed in or breathed out. Okay, during a forceful respiration, how much amount of air can be taken in and taken out? So obviously it is said taken in and taken out. That means the movement of air, the air which are in movement. Okay, so it does not include respiratory reserve volume. So we have to minus the respiratory reserve volume from the whole total of volume of air. Okay, so except the respiratory reserve volume, all the volume of air comes in the vital capacity. Okay, and the last one is total lung capacity. That is the total amount of air that can be occupied within the lungs. Okay, so it includes all of these volumes, right? Obviously, first of all, it includes the residual volume. Second one, during a forceful respiration, how much air is needed, that is also included. The tidal volume is also included, that is volume during normal respiration, and also forceful inspiratory volume is also included. Okay, the total amount of air that can be hold, that the lungs can hold. Okay, so if you are having any doubts, please ask. Thank you.